Welcome to episode 30 of 100 Days of Data. I'm Jonas, an AI professor here to explore the foundations of data and AI with you.
And I, Amy, an AI consultant, excited to bring these concepts to life with stories and practical insights. Glad you're joining us.
When we think about programming, the classic idea is that you write rules into a computer, but AI flips that around. Rules are learned, not coded.
That's such a game changer. Instead of telling a system exactly what to do, you let it figure out patterns and rules on its own. It's like teaching someone to drive versus programming the car to handle every scenario.
Exactly. Traditional programming is all about precise instructions. You spell everything out in a clear step-by-step way. The computer follows those rules exactly. No surprises.
Right. And that works really well when the problem is straightforward, like calculate the total price in a shopping cart or validate a user's password.
But the moment you deal with messier problems, like understanding spoken language or recognizing images, explicitly coding every possible rule becomes near impossible. That's where AI, especially machine learning, comes in.
I see that all the time with my clients, especially in retail. Instead of trying to predict customer behavior with rigid rules, they now let AI models learn from vast piles of sales and browsing data to figure out what might sell next.
So let's clarify some core ideas. Traditional programming uses rules, or algorithms, coded by humans. AI, particularly machine learning, uses data to train models that can make decisions or predictions based on patterns it found during training.
And this isn't just a small adjustment. It's a paradigm shift. Businesses no longer have to anticipate every possible scenario up front. They can rely on AI to adapt and handle variability.
Historically, programming started with manual instructions. Early computers were basically calculators for fixed formulas. But as problems grew complex, especially with the rise of big data, that approach ran into limits.
Think about voice assistants. Back in the day, engineers would have had to list out every acceptable phrase. Impossible. Instead, these systems now learn from thousands of hours of speech data how to interpret what you say.
Precisely. This move from rule-based to learning-based approaches represents a fundamental shift in how we build software. Rather than programming behavior line by line, we design systems that learn behaviors from examples.
But there's a trade-off. Traditional programming is predictable and explainable. You know exactly what the code will do. AI models, especially complex ones like deep learning, can feel like black boxes.
That's an important point. Understanding this split helps businesses decide what approach fits their needs. If rules are well-defined and the environment is stable, traditional programming might be the way to go.
On the other hand, if you're dealing with messy, changing, or high-volume data, like detecting fraud patterns in finance or recommending products online, AI's learning approach shines.
Let's explore the fundamental difference in how these two approaches use rules. Traditional programming depends on explicit rules crafted by developers. AI derives implicit rules by analyzing training data.
And this difference plays out in how you build and maintain systems. In traditional programming, if the business rules change, engineers update the code. With AI, you collect new data and retrain the model to adapt.
And that leads to the concept of feedback loops. AI systems improve as they see more data and as the environment evolves, something you cannot easily do with static rule-based software.
A great example is predictive maintenance in manufacturing. Instead of hard-coding failure conditions, companies use sensor data to train AI models that predict machine failures before they happen, continuously improving as they gather more data.
But this also highlights challenges. Training AI models requires quality data, time, and computational resources, whereas rule-based programs can be deployed quickly if the problem is simple.
I've seen manufacturing companies struggle with this too. They start eager to jump into AI, but realize the data isn't clean or enough, leading to disappointing results unless they invest in data preparation first.
This is why understanding your problem and data is crucial before choosing the approach. AI isn't a magic bullet for every case. Sometimes simple rules outperform complex models, especially when transparency and explainability are key.
And sometimes blending both worlds makes sense. A smart loan approval system might use rules for basic eligibility checks and AI for nuanced risk assessment.
A hybrid approach leverages the strengths of both. The deterministic rules handle firm requirements, while AI handles fuzzy or probabilistic parts.
That's exactly what we see in healthcare, too. For regulatory compliance, hospitals rely on strict rule-based checks. But for diagnosing diseases from images, AI helps radiologists by spotting patterns humans might miss.
Summing up, the classic programming mindset focuses on telling machines exactly what to do, coding explicit, rigid rules. AI flips this by having machines learn rules implicitly from data. It's less about instructing and more about teaching.
Which means businesses must shift how they think about building solutions. It's less about writing thousands of lines of code and more about collecting, curating, and learning from data, a totally different skill set.
That's the essence of the paradigm shift. Not just new tools or technologies, but a new mindset for solving problems.
And it opens doors to innovations we couldn't imagine before. From personalized marketing to autonomous vehicles, AI's ability to learn rules dynamically is transforming industries.
So, key takeaway. Traditional programming relies on explicit human-coded rules, perfect for clear, stable problems. AI learns rules from data, ideal for complex, uncertain environments.
And from the consultant side, knowing when to apply which approach can save businesses time, money, and headaches. Plus, blending both approaches can unlock powerful solutions.
Next episode, we'll dive into data preparation for AI, because how you prepare your data often makes or breaks your AI success.
If you're enjoying this, please like or rate us 5 stars in your podcast app, and we'd love to hear your questions or experiences. Send them our way, and we might feature them in future episodes. Until tomorrow, stay curious, stay data-driven.